Laboratory books and report forms. The record which the assayer makes of his work must be clear and neat, so that reference, even after an interval of years, should be certain and easy. One method should be adopted and adhered to. Where there are a large number of samples, 3 books are required. Sample book. This contains particulars of the sample, marks, etc., which are entered by the office clerk as they arrive. He at the same time puts on each sample the distinguishing number. Illustration. Example of a page of sample book. Reader's note. There are 4 columns: date, number, sample, and remarks. End reader's note. Date February the 1st, number 482, sample tough copper, remarks for arsenic. February the 2nd, number X, sample piece of metal, remarks for nickel and copper. February the 2nd, number 483, sample tough copper. February the 2nd, number 73, silver precipitate, 4 casks, 2400 weight 1/4, remarks with letter. February the 2nd, number 494, purple ore 200 tons. February the 2nd, number 1JT, lead ore 1JT, from Corsica. February the 2nd, 2JT, lead ore 2JT. End of illustration. Laboratory book. This is the assayer's notebook, in which he enters clearly the particulars of his work, the results obtained, as well as how these results were arrived at. The calculations should be done on scrap paper and should not be entered, although of course detail enough must be shown to enable the results to be recalculated. The assay book. This is the official book, and is a combination of the sample and laboratory books. It corresponds with the report forms. Without being loaded with detail, it should contain sufficient to characterize each sample. Illustration. Example of page of assay book. Under description of sample there are 3 columns: date, material, and weight, given in tons, hundredweights, quarters, and pounds. Then columns for number, water lost at 100 degrees centigrade, assay on the dry material, and date reported. End of illustration. When the number of samples is small, the sample book may be omitted, and the entries made in the assay book as the samples arrive. Report forms. These should entail as little writing as possible in making out the report. For general purposes, the form given on page 12 is useful. Reader's note. The assay note gives the address of the assay office, for example, Assay Office, the Mining School, Camborne, Cornwall, a line for the date, 2 lines for extra notes, then description of sample, water lost, and assay on the dry material. End of illustration. The quantity of substance to be taken for any particular assay depends largely upon the method of assay adopted. There are, however, some general considerations which should be remembered, and some devices for simplifying the calculations which should be discussed. The smaller the percentage of the substance to be determined, the larger should be the amount of the ore taken. The following table will give a general idea as to this. Percentage of the substance to be determined, between 100 and 10. Amount of ore, etc. to be weighed, 1 gram. Percentage to be determined, between 10 and 5. Amount of ore, 2 grams. Percentage to be determined, between 5 and 1. Amount of ore, 5 grams. Percentage to be determined, between 1 and 0.1. Amount of ore, 10 grams. Percentage to be determined, between 0.1 and 0.01. Amount of ore, 20 grams. The rougher the method of assay adopted, the larger should be the quantity of ore taken. If the degree of accuracy attainable with the methods and instruments at the assayer's service is known, it is easy to calculate what quantity should be taken for any particular case. If the results are good within 0.001 of a gram, then taking 1 gram of ore we can report within 0.1%, or if they are good within 0.0002 gram, taking 20 grams of ore we can report within 1 part per 100,000. or very closely within 6½ pennyweight to the ton. If it is wished to be yet more particular in reporting, larger quantities must be taken. The difficulty of manipulating very small or very large precipitates, etc., must be borne in mind. So too must the fact that the greater the weight of the final product of an assay, the less, as a rule, is the percentage error. The distinction between absolute and percentage error, often overlooked, is important. If 0.5 gram of silver be cupelled with 20 grams of lead, there may be obtained a button of 0.495 gram. The absolute loss is 0.005 gram, and this equals 1% of the silver present. Similarly, cupelling 0.1 gram, the resulting button may be 0.098. The absolute loss is only 0.002 gram, but this equals 2% of the silver present. In the same way, the student should see that the two results, 91.5% and 92.0%, are really more concordant than the results 9.1% and 9.2%. A device often adopted in practice where a large number of assays of one kind are made, and the report is given as so many ounces or pounds to the ton, is that known as the assay ton. The assay ton may be any arbitrary and convenient weight, but its subdivisions must bear to it the same relation as pounds and ounces bear to the actual ton. On the other hand, in a laboratory where many kinds of work are performed, different sets of weights of this kind would only tend to confusion, even if they were not unnecessary. With a set of gram weights and its subdivisions, anything may be done. If it is desired to report as pounds to the ton, then, since there are 2,240 pounds to the ton, a weight of 2.240 grams may be taken as the assay ton, and each 0.001 gram yielded will equal 1 pound. Or 22.4 grams may represent the ton, and each 0.01 gram a pound. Similarly, since there are 32,666.6 ounces troy to the ton, if we take 32.6667 grams as the assay ton, each 0.001 gram will equal 1 ounce to the ton. In some cases it may be convenient to have, in addition to the usual gram weights, one or other of the assay tons mentioned above, but generally it is better to work on a purely decimal system, and convert when required into ounces per ton, etc., either by actual calculation or by reference to a set of tables. End of section 1.